Hello, welcome back everyone. Today we are going to be doing some optimization problems involving exponential functions. So these are very similar to the optimization problems we did in Unit 3. The only difference is that the optimization problems in Unit 3 only involve rules we learned at the time. So they involve things like power rule, chain rule, quotient rule, and product rule. Whereas here, some of these problems are going to involve, taking derivatives of exponents, right? Optimizing functions that involve exponents, whether it's the natural exponential function or whether it's other exponential functions, as at this point we've learned how to do all of those. Okay, so let's do it. Let's do it. Let's start with reading example 1 here. Example 1 says, the effectiveness of studying for an exam depends on how many hours the student studies. Experiments show that if the effectiveness E is put on a scale of 0 to 10, then E of t is equal to 0.5 times 10 plus t times e to the negative t over 20, where t is the number of hours spent studying for the exam. If a student has up to 30 hours available to study, how many hours are needed for maximum effectiveness? And it also says in bold to check endpoints. We'll also need to check the endpoints of 0, how well would we do if we didn't study at all? If we study for 0 hours, which probably not a very good idea. Or what about 30 hours? What if we use the full 30 hours of studying time? Then how high a score would we get on our exam? Would it be enough to give us 100% on the exam? Possibly. Or maybe not. Maybe the highest we could get is only a 98. Maybe it's a very hard exam. Okay, so let's go ahead and do this question. So to find the max, we're going to set E of t prime equal to 0, right? We need to set the derivative to 0. Okay, so let's do it. Let's do it. The other thing I want to point out here is that this E of t is the same as 5 plus 0.5t times e to the negative t over 20. If we just expand the bracket, so I'm going to do that, it'll make our lives a little bit easier here, okay? So therefore, 0, which is what we're setting e prime of t to, would be equal to, well, the 5 just becomes 0, so 0 plus 0.5 e to the negative t over 20, right? Plus 0.5 t e negative t over 20 times 1 or negative 1/20th, right? Because again, we've got to make sure we take the derivative, okay? So here basically what I did, I used the product rule and also I suppose the power rule and chain rule too in order to get here, right? Because keep in mind that the derivative of t is just 1, right? So there would technically be a times 1 here. But we didn't have to include that per se. We didn't have to include the times 1 there. Okay, anywho, let's move on. So therefore we're going to have let's see, what are we going to have here? No, that's a good question. So let's first simplify this a little bit further. 0 is equal to 0.5 e to the negative t over 20, and then plus, let's put this in here and say negative, or I guess we'll just say minus 0.025 t e to the power of negative t over 20. So therefore, we're going to have 0.5 on the one side, and then on the other side we'll have 0.025 t e to the negative t over 20. Now if we divide both sides by e to the negative t over 20, what could we get here? We could cancel that, cancel, and we get 0.5 equals 0.025t, which makes t equal to 20. So therefore, it looks like that if we spend 20 hours, we will maximize the exam effectiveness. So therefore, we should study for 20 hours in order to maximize that effectiveness. Now, let's also look at the endpoints. So E of 0 equals to 5. So if we study for 0 hours, then our effectiveness is only 5 on a scale of 1 to 10. So we only get 50% on this exam. Okay, what about E of 30? If we study for 30 hours, and we plug that in, we get 8.3. And then what about E of 20, which is our maximum effectiveness? We get 8.7. So it seems as though if we go above 20 hours, we're actually lowering our effectiveness, right? Maybe that means that we're not spending time doing other things that are crucial for our health or things like that, and that those extra hours don't really add a lot of extra knowledge on. Whereas if we study for just the right amount for 20 hours, then we get some good effectiveness. So there's our endpoint check. That's basically just to go with what are the minimum number of hours and the maximum number of hours, and also show the the maximum point as well, and show that that maximum point that we're getting is higher than both the endpoints. Because if it wasn't, then there's a problem there. Okay, so therefore, in conclusion, to maximize effectiveness, study for 20 hours. Well, not really, at least according to this question. Obviously, how well you do on an exam depends on many more factors other than just how many hours you study for it. Also, the effectiveness of your study matters as well, and things like that, more than the number of hours. But according to this question, to maximize effectiveness, you should study for 20 hours. There we go. All right, so let's do one more example, and then I think that'll be it for us for today. This one says a mathematical consultant determines that the proportion of people who will have responded to the advertisement of a new product after it has been marketed for T days is given by this function. The area covered by the advertisement contains 10,000 potential customers, and each response to the advertisement results in revenue to the company of $2.50 on average, excluding the cost of advertising. The advertising costs $3,000 to produce and another $500 per day to run. So, what percentage of potential customers have responded after 7 days of advertising? Also, write the function R of T that represents the average revenue after T days of advertising, and also write P of T that represents the average profit after T days of advertising. And then, lastly, E, which actually looks like should be D, for how many full days should the advertising campaign be run in order to maximize average profit? Assume an advertising budget of $10,000. So, therefore, we can't spend more than $10,000. So, that's important. Okay, so let's do it. So, the first question is very straightforward. All it asks is what percentage of potential customers have responded after 7 days of advertising. So, we need to do F of 7 to find that, right? Because T is the number of days given, and here it's 7, right? And F of T represents the proportion, right? So it's going to represent the decimal number. So we'll just have to change it to percentage in order to find the answer. So F of 7 is 0.7, 1 minus e to the negative 0.2 times 7, like that, which is equal to 0.53. So therefore, 53% responded after 7 days. Okay, then it says write the function RT that represents the average revenue after T days of advertising. So basically, R of T is going to be equal to the number of people times the amount of revenue, or I guess the average revenue per person. Okay, so we already know that the average revenue per person is $2.50, but what about the number of people? Well, the number of people is going to be 10,000. 10,000, that's our maximum. And then times 0.7, 1 minus e to the negative 0.2 t, right? Because this tells us the proportion of people. So the proportion of that 10,000 is going to give us the number of people if we multiply it by that 10,000. Good. And then this is all multiplied by $2.50, which I'll just say 2.5 here, because on average, we make $2.50 per person here. So there we go. That's the answer. Okay. Part C asks, write the function P of T for profit that contains that or that represents the average profits after T days of advertising. So profit is equal to the revenue, so the money brought in minus the costs. Okay, so we already know what the revenue is, right? We already know that the revenue is equal to this number here. If we multiply the 10 and the 2.5, I can say this is 17. Yeah, 17.5, I think. Let's see. No, that isn't right, or is it? No, it is 17.5. Yeah, if we multiply here, here, and here together, times 1 minus e, negative 0.2 t, like that. There we go. So let's write that in. Okay, and then minus the cost. So what's the cost? Well, the cost is $3,000 initially just to run this campaign, plus an extra $500 per day. So that's the cost. So the profit in total is going to be 17,500 minus 17,500 e minus 0.2 t minus 3,000 plus, or sorry, not plus, it would be minus 500 t. So if we were to simplify that, we would get, let's see, 17,500 would be 14,500 minus 500 t minus 17,500 e to the negative 0.2 t, like that. So all I did here is I just, combined those two like terms there, and we're good to go. So all of these steps we've done, it may seem like, oh, it's a longer question because we have A, B, C, and D. This should be D, not E. But really, all these steps are necessary in order for us to get to this point. So even if they just asked part D, it would still be very good. Okay, it would still be very good because, we would have to go through all these steps anyway in order to complete part D. So I'm glad it's multiple parts because then that helps us to complete part D a lot easier. Because now we already have the profit function. It asks for how many full days should the advertising campaign be run in order to maximize the average profit and assume the advertising budget is $10,000. So to do that, first things first is we need to take the derivative of the profit function, which we just found. And in order to found it, we had to find those previous things as well. So all these steps were key in order to get to here. So the profit would be negative 17,500 e to the negative 0.2 t times negative 0.2, right? Because we got to take that derivative. Subtract 500, or sorry, let's see. What are we going to subtract here? We're going to subtract 500. That was correct, right? Because we're taking that. So minus 500. All right. So if we simplify that one step further, we're going to get 3,500 e to the negative 0.2 t minus 500. And now we're going to set the profit or not the profit to 0, but we're going to be setting the derivative of the profit function to 0 in order to get to the maximum profit. So 0 is equal to 3,500 e to the negative 0.2t minus 500, which means that e to the negative 0.2t is equal to 500 over 3,500, which is actually 0.14. Then I'm going to ln everything. I'm going to say ln e negative 0.2t equals ln 0.14. Of course, ln and e cancel, and we just get negative 0.2t on the left. And then ln of 0.14 is on our right. And then if we divide that out, we're going to get that t is equal to 9.83 days. Now, I don't actually think that we can run the campaign for a partial day, so I'm just going to say, well, I guess we're stuck paying for 10 days then, because 9.83 does seem awfully close to 10. So I'm just going to say we'll round up to 10 days, because I don't know that that we can actually just run it for partial days there. Okay. So let's also find the endpoint. So we need to find p of 0. So what if we run the campaign for 0 days? P of 10, and also P of 14 days, right? Because if the advertising budget is $10,000, right, if that's the most we can spend, then the most amount of time, longest amount of time we could do this advertising campaign would be 14 days, because it costs $3,000 initially, so that's already $3,000 eaten up. And then that $7,000 would last us 2 weeks, right? Because it's $500 per day for 2 weeks would eat up that other $7,000. So if we run the campaign for 0 days, well, that would be silly. At that point, we shouldn't run the campaign at all, because if we run it but run it for no days, then we're out $3,000. We have to pay $3,000, but then not the $5,000 per day. If we run it for 10 days, if we plug in 10 here, we're going to get $7,131.63 by plugging that in. And then for 14 days, it would be $6,435.82. So therefore, the maximum profit is reached after 10 days of advertising. So therefore the company, or they should advertise or run the campaign for 10 days. And there we have it. All right, well, that was all for today. Next time, we're going to actually learn about the derivatives of trigonometric functions, so sine, cosine, and tangent as well. So I'll see everyone then. Bye for now.